Now we want to solve this 3 by 3 system. That is 3 equations in 1, 2, 3 unknowns, the unknowns being x, y, and z. The methods for solving this equation are very, very similar to those we use when we have 2 equations and 2 unknowns. We can add 2 equations together. We can add a multiple of one equation to another, replacing either of the equations in any case. We can also switch to equations. In other words, if I, as I'm going to do, switch the first equation, first equation with the third, so this third equation becomes first, the first becomes the third, it's still the same 3 equations. There's going to be no difference in the solution due to simple interchange of 2 equations. Now, our goal is going to be to add multiples of rows to other rows, etc., and finally get x equals something, y equals something, z equals something. And these asterisks over here just stand for arbitrary numbers, whatever we get from the process. Because if we continue this process through the end, we will get that to where we have just an x in the first equation, a y in the second, a z in the third. We will get specific numbers here. Alternatively, we can write the augmented matrix for the system. And it should be very obvious how the augmented matrix is constructed. Each line represents an equation. The first number, the coefficient of x. The second number, the coefficient of y. The third number, the coefficient of z. And the fourth number, the number to the right-hand side of the equal sign. So we've got the augmented matrix here. We've got the system here. And I'm going to go ahead and work through these kind of parallel. We'll manipulate the equations and we'll do the same manipulation on the augmented matrix. Well, the first thing we want to do is we want to interchange the first and the third row, so that the next time, the second time here that we've written down the system, we're going to have the third equation from here in the first row and the first equation in the third row. We designate that over here just so we can keep track of what we've done and clarify exactly what we're doing. That 3 here indicates that this is the equation that was in the third row previously. The 1 here goes back to the previous and indicates that this is the equation that was in row 1 in the preceding. We can do this. We can use this notation where any of these circled numbers refers back to the equation from the preceding system, from the preceding version of the system. Since we never look back 2 steps, we don't really care when we go to this step what we had here. All we have to do is consider what we have here. This notation is always going to work. Okay, so this is what we have here. Now, similarly, here we just interchange the first and the third row. So that what was the third row becomes the first. What was the first row is now in the position of the third. Okay, now, having done this, and I want to talk more about the augmented matrix than about the system now, because ultimately we're going to want to do these things, solve systems of this nature using the augmented matrix. And we want to be able to do these matrix operations very efficiently. Okay, the reason that I switched these, the main reason, is it gave me a 1 here. Because our goal is, again, to get this system, if we're doing the system, and that's equivalent to getting this augmented matrix, where there's a 1 here, and zeros below it. A 1 here, zeros above and below it. A 1 here, zeros above it. So, having gotten the 1 here, it becomes pretty easy to get zeros below that 1. And we want to do that in the first row, our first column. We don't want to get a 1 here, say, and zeros below, because we'd still have to get the zeros over here, and in doing so, we'd have to add multiples of rows that would mess up the zeros that we got over here. And we'll see how that occurs, how that sort of thing develops. Okay, well, having this matrix, we simply add -1 times the first row to the second row. Because -3 times the first row to the second row. Because, of course, -3 times 1 is -3, so when we add that to 3, we're going to get the 0 that we have down here. And we're also going to want to add -2 times the first row to the third row. And that's, of course, going to give us a -2 here to add to the 2 and get us the 0 here. Now we can use the first row twice because we're not going to change the first row in this next set of operations. We will change the first row because, of course, we've got to get zeros here and here. But for right now, we're not going to change anything in the first row. And even if we did, we could still use the first row to add -3 times the first to this one and -2 times the first to this one. None of that changes the first row. So we write this. Now I wrote it over here on the equations. Of course, we're going to do the same thing on the equations. We do -2, well, second row minus 3 times the first row. So second row here, that's going to be our 3 and whatever else follows. And then -3 times the first row. It's going to give us a -3 here. That's how we're going to get the 0 here. And then for the third row, we do the third row minus double the first row. And that's going to work. Now, I've written out the rows here. The second row, and of course, we're talking about the second row of the preceding matrix, the second row, and we subtract 3 times the first row. Well, 3x minus 3 times x is, 3x minus 3 times x is 0. I caught it 2 out of the corner of my eye and thought I'd done something wrong. Okay. Then, excuse me. Okay, again, doing the second row minus 3 times the first. We get 3x minus 3x gives us 0x. Then -2y minus 3 times this one, 3y now, is going to give us -5y. And 4z, and then we got to add -3 times z. 4z minus 3z just gives us z. And -3 minus 3 times 1 gives us -6. Now we do the third row, which is third row of the previous, minus 2 times the first row. So we get third row 2x minus 2 times the first row is going to be minus a 2x, giving us a 0x. A 3y minus 2 times the y gives us just y. -4z minus 2 times z gives us -6z. And 1 minus 2 times 1 gives us -1. Or if we're looking just at the rows, we're doing, and let me go off camera and write this stuff out. I don't like working over here and having to refer all the way back here. Actually, I don't mind working from here to here, but I feel like I'm blocking what you need to see, and I'm sure I am. I think it's easier for you if I put it over here. So I've written down the operations over here. They're the same as the operations I've written down over here. So again, I'm doing 2, which means second row of the previous, minus 3 times circled 1, which means minus 3 times the first. So we're taking this minus 3 times this minus 3 times this minus 3 times this minus 3 times this. 3 minus 3 times 1, well, that's 3 minus 3 is 0. Minus 2 minus 3 times 1 is 2, minus 2 minus 3 is -5. 4 minus 3 times 1 is 4 minus 3, which is 1. -3 minus 3 times 1 is -6. And then we do the same thing, except that we're doing the third row and subtracting double the first. So we do 2 minus 2 times 1 to get 0, 3 minus 2 times 1 to get 1, -4 minus 2 times 1 to get -6, 1 minus 2 times 1 to get -1. Now, if you can't do that on site, and it's actually a good idea when you're first doing these, as we've done before, over on a piece of scrap paper, write out this row, write out -2 times this row below it, and then add them. Write out this row, write out -2 times this row, and add them, or do the same with the equations. Okay, now you see we're making progress. Our goal is to get a 1, 0, 0 here, which we have now in the first column. And now we'd like to get a 1 here, zeros above and below. Well, the easiest way to get a 1 here is to make the second row the old third row, because we notice that the third row here, and I was about to point up here, but we're in this matrix and we're referring back to this one. Okay, the third row now has a 1 in it, so that's very convenient. So we simply switch those 2 rows, and now we've got a 1 here. Okay, so it matches the 1 that we want here. And of course, we do the same thing here. We switch the second and third rows, we get a single Y here. So this row becomes the third row from before, this row, or this equation becomes the third equation from before, and this equation will be the second equation from before. Now, the next thing we do is we notice that, okay, if we're working over here, if we subtract the second row from the first, we get a 0 up here, don't we? And if we add 5 times the second row to the third, we're going to get a 0, because we'll have 5y and -5y. And by the same token, just looking at the numbers, if we subtract the second row from the first, we're going to get a 0. If we add 5 times the second row to the third, we're going to get a 0. And that's going to give us what we need in the next version of our, or the next step of our analysis.